This here is my wife's little bedside alarm clock, and it's this Timex Indiglo night light. The top here, where it's all white, is supposed to light up. You can push down on here, and it's got two little buttons on the bottom. And when you do that, it's supposed to cycle through colors. And on the back, we have an adjustment for that, for the dimmer, so you can have low, medium, and high. And then we've got the other buttons here for like setting the time and alarm and stuff, and then this other button. It used to light up, but slowly it started getting like dimmer and dimmer, even if you had it like on the highest setting here, until the point where the light just completely went out.
Just like the light in my heart.
And I mean, I have no idea. If it was like something that, you know, like say the cord would have broken, I don't think it would have done that. It would have just completely gone out at once. And the power supply here is just this little Woolwart transformer, 4.5 volt DC, 150 milliamp. And so I kind of doubt that there's anything wrong at all with this, just because of the fact that it got dimmer. It didn't just completely go out. I've never opened it up to see, you know, how the LEDs inside are arranged. I don't know if it's like a single RGB LED or if it's got like three, one for each color or whatever. So we're gonna open it up. Down here on the bottom, we just have our battery compartment. I believe this had a 9 volt in it. Oops, pushing buttons. Jeez, I really don't want me getting into this battery. There it goes. Oh, never mind. It's got a 2032. So that's for the time back up there, and as you can see, it's still got the time. So that's what that's doing. Here's the plug-in for this transformer. So this should just pull out, if I could. Okay, I kind of can't do this one-handed. Okay, once again, this should just pop out. There it goes. All right. So I guess we should check power to here, make sure that we're getting something. Okay, if we've learned anything here recently, is that we should check the power supply and see if that's even working. So let's check and see if this power supply is working, and it is. And since it's just a little transformer there, it really doesn't have any regulation. So even though it says it's a 4.5 volt power supply, it's putting out close to 9. I mean, I don't know if that would have had anything to do with it going dim like that, but I guess we will find out. So what else do we got here? We have 4 little screws. Hoping that this allows the whole top cover to come off. Okay, there's the last one. With that high voltage output on the transformer, I'm kind of assuming that this is going to have some sort of regulation built in. I mean, it's got to. Okay, so now this is, yeah, so this whole thing is trying to come out, it seems. Okay, never mind. Only the bottom part here is coming out. And okay, we got to be careful there. We've got the zebra strip here going from the bottom to up here where the LCD is. Oh, geez. Okay, so how can I do this? Oh, I see. Okay. I didn't really need to take that apart at the bottom, I guess it seems. It's got these little plastic tabs here on the inside on the white part, and then those clip into the clear casing on the outside. Although I don't really see any way that this would have been easy to get to from the... Let's see if we can... Maybe if I squeeze here I can get these to come out. Okay, I think this screwdriver here should do the trick. There we go. Okay, so now this whole thing is sliding out. There we go. Alright. Now how does this white piece come off? Okay, this piece is going to be slightly tougher to take apart because if we look inside here, it might be a little hard to see. There's a little plastic clip way in here, and it looks like it's got some screws as well. So let's see, maybe if I squeeze these in I can pop that gray part out from the back. No, that's not going to work because see that screw right there? That one. It's mounted to a little post right here on the, sorry, it's hard to see there, but there's a post on the white plastic that screw is screwed into. So it looks like maybe the LCD part is supposed to come off first. And of course that's going to be like the more difficult one to remove, because the strip is right here, and I'm already kind of stretching it out a bit there, and I'm trying not to break it. I guess if I kill it completely, I order a new one. Yeah, there we go. Okay, this popped out, and here it comes. The other side won't pop out. Let's see if we can do it like this. Okay, that seems to be working. There it goes. All right. Okay. So this little white dome here is where our LED is going to be, and it looks like it's screwed in from the bottom, possibly. Can't tell for sure yet. I'm wondering if this will pop out. Let's see. Not easily. Okay. Alright, funny thing here. They've got 3 holes on this white dome, but they actually only have 2 screws holding it in. There's one here, and there's one up here. The one right here, there is no hole on the board for a screw, and I can actually see right through the hole. And looks like there's a trace going through underneath. I'm not sure if that is a trace or not, but it looks like something's like right underneath that hole. So I guess while we're in here, we can check voltage at this, in this area here. It looks like this might be a regulator right there. It says U2. So that might be our little 5-volt regulator or something. And then there's a diode right here, another diode here, and a couple caps. So let's see what's going on in this area. Alright, so first of all, let's see that we're getting our close to 9 volts here at the input, and yes, we are. What they have here is they have the barrel connector up mounted on this board here vertically, and that's held in by these 2 screws, and then they've got a couple wires coming off of that and going into this section of the board. So this was negative, right? And this was positive? Yes. Okay, so we'll keep this one on the negative, because that negative here seems to kind of like snake down and around and goes off in that direction. So what we're going to be regulating here is going to be the positive, and after it goes through a diode first. Let's see at what point of this regulator we have our 9 volts here. It's not that one, it's that one right there. So we got 8.12 going to the, well, what I'm assuming is a regulator, and at the other side we've got 3.3. So okay, so it looks like it might be a 3.3 volt regulator, and yeah, okay, and then that goes through another diode, which drops it down to 3.1. Okay, so and then that looks like it goes off elsewhere. There's actually a capacitor down here and a little electrolytic on the bottom underneath that section, so that's probably going to be for filtering that 3 volt. Okay, so that 3 volt then goes off into that section of the board. If we take a closer look at this section of the board here, so what we have is we've got the positive from the power supply coming in here. It goes through this diode. This diode splits off into this the regulator, and then it also has a lead that comes straight out of here into this little ceramic cap, and then it just kind of snakes off in that direction. So I have a feeling that this part right here is probably going to be for powering the LED section of the board here, and then the 3 point well, it's 3.3 at like this point here, but then after the diode drops it, then it goes into this the cap there, and then this 3 volts on this side. I have a feeling that this 3 volts is probably for powering the clock circuit. This other trace that kind of goes off here, this is just the ground. As we can see, it kind of goes off in here underneath the diode over in this area. So this is the negative from the power supply. So here's another ground. So this ground and that 3 volts over there for, I'm pretty sure, the clock. And then these other 2 for the LED. So I thought removing the 2 screws from up here, the one down here, there was one here, and then there was one in this corner here behind this ribbon cable. I thought that would allow this to, you know, just this would slide up, and then I could kind of take this whole thing here and just kind of flip it over, because we've got the little piezo here on in the plastic, and it's glued in there, so I don't really want to mess with the wires with that too much. But they glued this in here too, so I'm gonna have to pry this out. Okay, that wasn't as hard as I thought it was gonna be. It's like really soft rubber cement. So there's that. Now I should be able to take all this, just gently flip it. Oh, I forgot about the 3-volt battery on the bottom there, but the connectors or the contacts for that just kind of popped out. And we can see that the clock is still powered. It's probably from the power from this capacitor here, but it's just slowly fading away. Okay, so that gives me access to those 2 screws that I was talking about here. Now I can flip all this back over. Alright, they're actually using 3 separate LEDs there for the red, green, and blue. Okay, so here's a much closer look at that. So here is our 9-volt line coming in. Goes up here, and then it comes up, and then it goes through a resistor for this LED here. Goes off to here. Here's another resistor for this LED, and then here's the resistor for this LED. There is some stuff here that kind of looks like, it almost looks like glue, but I'm pretty sure it's just flux. And yeah, it's scraping off, so I'm pretty sure it's just flux. But if we look inside the LEDs, they are really dark. I mean, and it's not just this stuff on the outside. So I'm pretty sure they're probably being overdriven here, and they probably just, the little element inside just kind of basically burned out. They all look pretty dark like that. This one here more so than the other two. And each LED then also goes to one of these, what I'm pretty sure are transistors. So they would probably be like, you know, PWM driving these to get different intensity levels on these LEDs. But I have a feeling that we're probably just gonna have to replace these, and that'll probably get it working again until these go out. If we look at these resistors that are going to the LEDs, they're only 100 ohm resistors. So let's say assuming 2 volts per LED with I don't know, let's just say 20 milliamp drops. That's yeah, these are like way too low, especially at 9 volts. So I have a feeling that's probably why they burned out, because they're having way too much current being driven through them. So I think what would be the best thing to do is maybe stick like a small 5-volt regulator somewhere before all this stuff to, you know, drop it down to a much more controllable level. Because yeah, LEDs should not look like this. I used this solder wick to remove the solder from all the pins there on those LEDs, and I was about to say it kind of sucks that it doesn't say which LED is which, and I mean, at this point it's not like we can really be able to test each LED to figure out which one's what. But when I flipped it over and I started removing this foam pad, I realized that underneath it tells you which LED is what, so that makes things easier on us. So there's all our LEDs, and then it's also got the positives marked, which I mean wouldn't have been hard to figure out anyway, but at least that's helpful. Alright, I should just be able to pull these out here easily, somewhat easily, not easily. Let's see if I can pop them out from the other side. There we go. At least okay, blue one's out, almost. And this red one here is being a bit stubborn, but there it goes. Alright. Got the new LEDs here, and they're, I mean, it's not actually new. I've salvaged these from some other stuff that I had laying around, but kind of shaped the leads a little bit close to what they had there. They're not as close to the body of the LED as the old ones, but should work. Okay, I got my 3 new LEDs in there. The green one, there's the one that I had with the shortest leads, but like I said, I kind of salvaged these from some other stuff, so it's just barely going to be enough to solder it, but it's going to work. The other two you can see had much longer leads, so I'm just going to clip those. But already we can tell that there's a major difference between the clarity on these and the old ones. Alright, there we are, soldered in and clipped. Alright, let's do a little test here. I've got the connector here mounted on the top just to make it easier for me to plug it in and unplug it, because it's really difficult to do it on the bottom there. And already we can see we've got red and green lit up there. If we push the buttons, it kind of cycles through. So, and no blue to be found. What the heck? I have the dimmer on the lowest setting too, just to avoid running too much current through those. But we can well, I don't know if you can tell, but I can tell that, yeah, they're rapidly being switched on and off. Did I hook that blue up backwards? I hope not. Alright, well I guess at some point while I was bending the leads for this LED, this is the blue one, I guess I must have gotten something broken inside here, because if I touch it with a multimeter I can get it under diode test, I can get it to light up if I like squeeze the leads together. So yeah, this one's like got internal damage, but I found another one and this one is fine. So let's see how that looks. I haven't powered it up yet, assuming I didn't screw something else up. So goes that, and I'm assuming they're all probably going to be on. So there we go. So we've got red, green, and blue on, and you can kind of see it pulsing there. And that, yeah, it's because they are being pulse width modulated. So now when we push these buttons here on the bottom, it should cycle through different colors. So there's just green, there's just red, and there's green and blue, or green and red, just blue, green and blue, white again. Whee! Turn off the rest of the lights here so that we can get a better look at this. But now we know that the LEDs are working and that there's nothing else wrong with the circuit driving the LEDs. But now we've introduced a new problem because of the fact that we don't know the original specs of the LEDs that used to be in here. On these new ones, the blue one is like super bright compared to the other two. The red one kind of like trails behind, and then the green one is just like nowhere to be seen here. So with all three of them on here, this, you know, would normally appear to be white. But if we take this cover off, we can see that the blue one is just, oops, and I'm pushing buttons. Let's put it back on what would be white. And right there, all of them on. The blue one is just like oversaturating things. And I mentioned towards the beginning that maybe we would have to do something about the voltage coming into this board, because as we saw, it was like closer to 9 than anything, when the little transformer was saying it was supposed to be like 4.5. Instead of adding a regulator or something, we can just or should be able to just switch out the resistors driving the, or going to the LEDs that are limiting the current. But like I mentioned, since we don't know the exact specs of these LEDs, we can make some guesses, and I think we might be able to get something that's close enough. So looking at the board here closely again, we can see that they've used 10 ohm resistors going to each of these LEDs. And I measured the voltage at the positive and then the negative inputs to the driver transistors here that control the LEDs. And we're getting about 6 volts, you know, after there's some load put on the DC power supply. So as I mentioned earlier in the video, even though the power supply says 4.5 volts, because it's a transformer based one, usually the open circuit voltage is a lot higher, and we saw that we were getting like close to 9. But at this point here, like say where the positive comes in and the negative going into these transistors, it goes down to about 6 volts when it's operating. So what we're going to do is we're going to measure the voltage drop of these LEDs using the multimeter, and then we're going to select some resistors that give us a bit more adequate current values for these LEDs, because at 10 ohms, assuming a voltage drop of about 1.2, we're assuming here, let's say 1.2 volt voltage drop across an LED here that requires 20 milliamps with 10 ohms and 6 volts. According to calculations here, just some simple math, we're looking at about 480 milliamps going into one of these LEDs, assuming, you know, also like 100% duty cycle. That's way too much for one of these little things. And also, this thing doesn't need to be like super bright, because it's just meant to be kind of used as a sort of a night light, you know, and then you can see the clock from the light illuminating it. So what we're going to do here is we are going to remove these resistors, measure the voltage drop across each one of these LEDs, and try to come up with a resistor value that we're going to, I don't know, I guess we'll go with like with 20 milliamps, and you know, and then we'll get some resistance that should give us something closer to that. And I think that would probably be a lot safer for these LEDs than these 10 ohm ones we've got right now. And then changing the resistor values to give all these LEDs, you know, maybe some more of a more manageable current. Hopefully maybe we can also kind of get the brightness levels to be about the same, just so it's not like oversaturated with blue and red here, and then this green has like no chance. Although one thing I did notice is when I was operating this green one, I don't know, it just doesn't seem like it's very bright overall anyway, so I might even end up having to replace it. At one point when I turned off the red and the blue one here and I just left the green one on, it looked like it was starting to get slightly yellowish, and I think maybe that's because it's just being overdriven. Alright, so this is what I measured. I measured 1.68 volts at the red one, 1.83 at the green, and the blue one measured at 2.53. So we're going to take our 6 volts minus our voltage drop across the LEDs, so 1.68, and then we are going to divide that by the current we want. In this case we want 20 milliamps, so 0.02, and then we're going to punch that into our calculator. So it's going to give us 216 ohms for our resistor for the red, and then we're just going to do the same for the green and blue. Alright, so I did the other two, and that's what we got. And like I said, just quick and dirty math. It's nothing really complicated, just so we can get this thing working and, like, so, you know, some safe margins. I think 20 milliamps is it should be pretty reasonable for this. They might be slightly less, or they might be more, like able to tolerate more, but we're just going to keep it at 20. I haven't really had any issue with running too much stuff at 20, so we're just going to give this a shot. Oh, and another thing, we're probably not going to find resistors that are these exact values, not unless we go into, like, you know, something really, really precise. So we're just going to have to get something like within that ballpark, and that should work. Okay, like for example, for the blue one here, I found these resistors here that they have a marking of 181, so that's 18 with the 10, so that's 180 ohms. So this is close enough for that. For this one here, we're probably gonna find maybe something along the lines of like 201, so it'd be 200 ohm. Or with these, I could also go with like a, you know, like a 221, and for this one like a 211, and that would be like 210 ohms, and then that would be like 220 ohm. Only problem is I don't have like 210 ohm resistors or anything, so, but I do have 220, so we're just gonna use 220 for both of these. Okay, the new resistors are in, and the only thing I kind of had to do that's a little funky is that I had to sort of put them at an angle like this and jump them some spots. Over here I had to scrape some of the solder mask off just to get a pad there so I could solder it across, because the original resistor sizes were like 0805 or something. They were smaller, and these are 1206, so they didn't quite fit on the pads there very easily, so I just kind of make do, so that's why I look a little funky. But I checked the resistances and there's nothing shorting or anything, so they're fine. So now let's see how it looks here, just as is. And that blue is still a lot brighter than both of the other ones, but we might just have to make do. That red and the green look a little more even, but yeah, that blue's still crazy. But it doesn't matter, because, or it doesn't matter too much, because the blue wasn't really used much anyways. Although it might come in handy if we need to be like really bright or whatever. So I think I'm probably just gonna leave it as is. I'm not gonna worry too much about it. Like I said, this was just to it looks a little bit wider, but I think I would have to put like a bigger resistor there for that blue one. Maybe if I did like a 220 for that one as well, it might look a little bit better. Let's give it a shot. Okay, so here's blue with a 220 ohm resistor. Oh well, we'll just leave it. It's fine. Okay, but now that we actually have the resistor in there doing some limiting, let's see how the medium and high brightness goes on this. So that was medium and then high. Yeah, that blue one just like takes over everything. Green one, kind of dim. Red, that would be like orangish, just plain blue. That would be kind of like a teal color, but you can barely even see the green. I would probably have to get like a brighter green for this to like even look any better. That would be kind of like a purplish or pink right there, and then back to white. But oh well, we're just gonna leave it as is. The whole point was to just get this thing working again somewhat, just so you can see it in the dark, and so it illuminates a little bit, but not too much, because you don't want the whole room to be bright. And yeah, that'll have to do. And that way, hopefully with the resistors, it'll prevent LEDs from burning out too soon again. Alright, I got the clock put all back together. I set the time, and we're going to give it a shot here in complete darkness and see how it looks. Right now the dimmer switch in the back is set to the lowest setting, so let's turn this off here. Now we're in complete darkness and we're plugging it in. And I believe that's supposed to be white right there, but of course it looks pretty bluish. The blue just takes over. But like I said, it's not a big deal because the whole point is just to be able to sort of see the time in the dark. And as we push this button here, it'll cycle. It's supposed to be green right there, but the green, it's like super dim. And then red, you can kind of see it, which is okay. And that was to be like orange, and then that was supposed to be just blue. Yeah, so that's what we got. So let's see now if we go to medium. Of course it gets a little bit brighter, and it's not too bad. That should do. And then that's the brightest setting right there, and it does get a little bright in the dark here, so it's probably not going to get used in the highest settings all the time, but there we go. At least we can see what we're looking at. So well, that was it. I almost didn't even do a video on this because I thought it was going to be pretty boring, but as we can see, even the seemingly simplest looking repair can get kind of complicated if you start, you know, cobbling stuff together like I did here. But like I said, it's nothing critical, so this should be fine. This will work for its intended job. So thanks a lot for watching, guys. See you guys around the bench.